Hello and welcome to a new conversation on our YouTube channel. I am Alex Bolboaca, coming to you from the Mozaic Works studios, and today I have a very special guest, somebody who is an architect but thinks about developers when doing architecture, and this is very different from what we usually see with software architects in companies. So it will be a very interesting conversation about architecture and how to make diagrams that are actually easy to understand by developers. I'd like to welcome Simon Brown.
Hello.
Hello, and thank you for coming. First of all, can you please do a quick biography of yourself? I know you live in Jersey, which is already an interesting thing because it's an island that's kind of in UK but kind of not in UK, and you like to surf. Anything else that's interesting?
Yeah, so you're exactly correct. I do live in Jersey. Jersey is, so this is complicated, and you're going to wish you hadn't asked me now. So Jersey is part of the British Isles, but it's not part of the UK. And therefore it's not part of Great Britain and not part of England. So it's a crown dependency. That's the official term, and it's a little island just off the coast of France. My background, I actually worked and lived around London for best part of 12 or 13 years. And when I was in London, and I kind of moved to London straight after graduation, I worked for a bunch of small consulting companies, mostly building software either with our customers on joint teams or for our customers in the typical kind of outsourcing type approach. So my first projects I ever worked on was with a technology called Power Builder. Have you come across Power Builder before?
I missed this one.
No. Right, yeah. So it was kind of late 1990s, and it was just when the 4GL thing was becoming popular. So Delphi is another good example, of course. So I did that for a while. And then I saw this Java thing kind of emerging in 97, 98. I think I first came across it. Taught myself Java, managed to wing it so I could get on some Java teams, and my career kind of progressed from there, really. So started out as a developer, did what most people do, move through the ranks, get promoted, take on bigger responsibilities, and eventually moved into becoming the tech lead designer / architect on various software teams. So most of the teams I've tended to work with have been quite small, by which I mean less than 10, maybe 20 people. I have worked on a couple of gigantic projects, and they were horrible, and I don't want to ever do that again. But I've kind of seen how both size projects work. So yeah, I worked in London for about 12 years. I moved to Jersey in Channel Islands, where I live now, about 10 years ago. And there's not much, so my background from a technical point of view is Java, and there's not much Java here in Jersey. It's only a tiny island, 9 miles by 5, but there is a decent amount of .NET. So I kind of cross-trained onto the C# ASP.NET type stack, and did a bunch of consulting company type stuff for finance companies over here, again using the .NET stack. And for the past, I guess, 5, 6, 7, 8 years, I've been an independent consultant, now specializing in software architecture. So what that means is I get to run training courses and workshops, and I've visited over 30 countries over the past few years, and I get to do some other stuff as well. I also have another company that I run called Structurizer, and that is a set of tooling around software architecture diagrams, which I'm sure we'll mention later at some point. So that's my background in a nutshell, I guess.
Yeah, so I think we met the first time at ITACON conference when you were a keynote, and then we kind of bump into one another at conferences in London. And but what I remember from your talks back then, it was also kind of the beginning of microservices, and you
Yes.
had a very pragmatic approach to the idea of components and how to split things into components, and that not necessarily you need microservices. Do you remember what this was about?
I do, and that actually still happens. So yeah, microservices was being super hyped at the time, and this is only a few years ago, of course. and everybody was jumping on the microservices bandwagon. Like, oh, Netflix does microservices, so we need microservices as well. And everybody was going crazy for it, and they were sticking services and Docker containers, and they were breaking up their monoliths. And half the companies didn't really know what they're doing, and maybe still don't know what they're doing. And they would take their existing horrible monolithic code bases, and they would kind of slice them up, and they would stick, most of the time, synchronous JSON over HTTP calls between things in their code base. And they basically ended up building a really horrible distributed monolith, which all had to be deployed in a single go. And I just wanted to kind of get people to stop doing that, because it's not a very effective way to build software. So yeah, I had a bunch of talks at the time called Modular Monoliths. And it was basically about, okay, so Java doesn't have great support for building proper first-class components unless using something like OSGI or the Jigsaw stuff, of course. And it was basically a way to leverage the compiler to do some of that modularization for you. And you can still find that talk online, actually. I did it at a conference in Berlin a couple of years ago, and they recorded the most recent version. So yeah, fun times. And now it's serverless, of course, serverless and Kubernetes. So we're still doing the same thing, just with smaller chunks.
What happens with serverless now? What are the big problems that you see with your customers?
It's exactly the same. So whenever I run my workshops and people do the design exercise, and the design exercise I present in my workshops is really simple, really small. And often you see these serverless solutions, which are like a dozen serverless things, like functions as a service running on AWS or something. And then the people say to me, we're having a really hard time drawing the architecture diagrams to express what we want to build. I'm like, yeah, because your diagrams are complicated because you have a complicated solution. They're like, oh, do you think so? I'm like, yeah, you really do. So it's the same thing again. People are, again, they've seen this functions as a service, serverless stuff out there, and they're like, how can I use that? Not, is that the right thing to use, but how can I use that in my systems and my architectures? So yeah, we're seeing the same things, unfortunately. We'll learn one day.
All right, so this brings us to an interesting conversation about architecture. I've noticed discussing with developers that architecture is often quite difficult to define. It's a fuzzy term. It doesn't make a lot of sense. If you start going into details, very few people can tell you something that's coherent about what architecture is. And that's why I like to ask this question to people who have a lot of experience with architecture. What is architecture for you?
Architecture for me is basically two things. So it's structure and vision. And using those two words, you can actually group lots and lots of stuff. So when I talk about structure, imagine you're building a software system. If you look inside that software system, it's made up of smaller things, isn't it? Smaller building blocks. Now, we don't normally use the term building block. We normally use other words like module or component or subservice or, these sorts of things. So really, a lot of the definitions you'll find around architecture revolve around structure, and it's really looking at the building blocks, the smaller level, lower level building blocks that make up the software system, and also how they relate to each other. So there's a structural element to most definitions. That's kind of half the story, and that's a really important part of the story, but it's half the story. And the other part of the story is really about vision. And by vision, I guess I mean a couple of different things here. So imagine you're sitting at your desk at work with a blank sheet of paper, and somebody comes over to you and says, right, I would like you to go and build a software system that does X, Y, and Z. So you have to take that vague notion of an idea, of a concept, of a set of business features. You have to understand it. You have to translate it into a technical solution, doing analysis and event storming and all that other stuff. And then once you have an idea of that technical solution in your mind, you then have to figure out a way to visualize and communicate and describe that thing so that you can then set up and create a vision that the team will work with as a starting point. Now, of course, whenever you say things like this, people start to immediately say, oh, now you're talking about ivory tower design and dictating and telling people what to do. And that's not what this is about at all. So the complexity around architecture, of course, is really choosing the right sets of technologies to deliver the benefits that you need to deliver. And also figuring out the appropriate decomposition strategy. So maybe that is serverless or microservices, or maybe it's sticking stuff in the monolith with, high-level coarser-grained components inside it. Well, when you're architecting a solution, when you're doing design, it's really technology and modularity are the significant decisions. So Grady Booch talks about architecture, and he says architecture is about the significant decisions. That's really what I'm talking about here. So it's about figuring out the significant decisions and how your solution therefore satisfies your important or major or significant architectural drivers, by which I mean performance and security and scalability and so on. And we could go back to the stuff we did 20 years ago and have that horrible big architecture phase where we do all the thinking and then we come up with some sort of magical blueprint and then we ship it to a bunch of coders and they just magically build it. And that doesn't work, and that's definitely not what I'm recommending here. I have seen teams do the opposite though. So they basically said to me, we're doing the agile thing and therefore we don't think we should do architecture because it's not a part of what we're expected to do in extreme programming or something. And many teams have kind of gone from one extreme of doing everything to the other extreme of basically doing nothing. And I think there's a sweet spot in the middle. And my sweet spot in the middle is figure out what's significant, figure out your significant architectural drivers, your significant non-functional requirements, if you want to think of it that way. Figure out the significant decisions you want to make about technology and modularity, and put an initial, and that's the key word here, an initial starting point in place for that vision. So you're kind of using architecture as a basis to lay out a direction so that we can progress with the build of our system. And of course, that direction could and likely will change once you start to write code and get feedback and all that good stuff. But it's about setting that initial direction. So you're not completely wandering aimlessly around a landscape. You have some sort of focus and direction in which you're heading. So that for me is really what architecture is all about.
That makes a lot of sense. About you mentioned things like performance, security, and all that stuff. This is, if you look at the definition of architecture, these types of requirements are part of an architect's job. At least that's what I believe they should be. However, there's a lot of complexity there, and it's getting more and more complex nowadays. If you want to do performance on serverless, for example, or event-driven, or it starts to get quite complicated, not to get into security. That's a topic all in itself. So how do you deal with these kind of specialized things, but that you need to know a bit about as an architect? How do you deal with this?
I guess in the old-fashioned days, like 20 years ago, you would expect your architects to be experts in everything. So performance and scaling and security. And of course, that's just not possible anymore, given the range of different technologies we can use and design approaches and decomposition strategies. So I think perhaps a better way to do this is to lean on and use the team members you have available. So a bunch of people I work with, they have a very collaborative approach to architecture. So for example, they admit that they're not security experts, but in their organization or maybe in their team, they do have security experts, and they'll bring them on board. And the architecture and the design stuff is much more collaborative than it perhaps was, say, 10 or 20 years ago. So that's really the thing here, admit you don't know everything and go get help with the bits you don't know. You've also got this whole full stack developer thing, which is a term I really dislike. We should have everybody be full stack developers. Well, that sounds great in theory, but then every developer has to know how to tweak CSS and HTML and deliver Angular apps, and also do all the server-side stuff in Java, and also tune database indexes, and that's just not possible. And I think we do need to go back to leaning on specialisms and really appreciating that different technologies have different specialisms. It's a team game at the end of the day, isn't it?
All right. So you need to be kind of a leader, but who also collaborates with a lot of specialists, basically trying to bring in.
Yeah, exactly.
Yeah.
It's a leader rather than a dictator. Big difference. Big difference.
Yeah. I know that with Rebecca Worfsbrock, her favorite way of talking about architects is a steward of architecture, a steward of products. which is it's a bit hard to explain for non-native English speakers, but it's how do you explain stewardship? That would be interesting.
How do I explain steward? I think I would do the same. So it's the direction thing. So we're trying to steward, we're trying to guide the team in the same direction, and in order to do that, we need to know which direction we're going in, of course, which is why the whole design stuff is important in the first place. But yeah, stewardship, guiding, that makes sense.
Going back to your switch from programmer to architect, we have a lot of people in the audience who are programmers and they are interested in architecture, but they are facing challenges switching to this type of job. What were your challenges and how did you deal with them?
I guess my biggest challenge was that nobody prepares you for the role. So one day you're a programmer on a team and then that project finishes, and then the next week you start on another project and somebody says, by the way, you're leading this, you're the architect. You're like, oh, thanks. There's a great book by Patrick Qua, and it's a bunch of interviews and stories with people in tech lead roles. And by tech lead, he basically means people who are in architecture positions but still writing some degree of code as a part of their day-to-day job. And all of the stories in there are really interesting. It's basically the tech stuff is mostly okay, and we can figure out the tech stuff, but nobody teaches you how to deal with people. And that's the big thing here. I think the biggest jump between programmer and architect is one of people, because now you're leading people, and the soft skills, the interpersonal skills, become much, much more important. So when I worked in London, I used to be part of the team of people who interviewed candidates to come and join the company and work with us. And when we did developer interviews, we would always test them on their Java knowledge and all of that stuff. But the interviews were basically very technically focused. When we did the architecture interviews, we also wanted to make sure that the people had good tech backgrounds, but we also kind of wanted to drill into their soft skills. So how do you deal with these sorts of situations? How do you communicate your ideas to teams? So I think that's the biggest jump. The other problem people have generally with moving from being a developer into an architecture role is that where do you go for information? So one of the biggest things I struggled with was, I'm a developer. You can go onto YouTube, you can go onto blogs, and there's tons of articles that tell you how to get stuff done. The same, certainly when I moved into my architecture role for the first time, was not necessarily true. So there were lots of architecture books, software architecture in practice and all that sort of stuff. But these are big, thick books written by researchers and academics. And one of the things I didn't really get my head around at the time was, how does that apply to me? So if somebody asks me to go and be an architect and lead a team, what on earth do I do? Do I have to use all these formalized methods I've just read about? Do I have to go learn a whole 700 pages of the UML spec? You know, what's important? And that's actually what led me to write my book, Software Architecture for Developers. When I worked for these consulting companies in London, so let me backtrack for a second. If you work for a consulting company and you want to grow and scale your consulting company, you need to hire more people so that you can then go service and work with more customers. If you have more people, you have more software development teams, and that means you need more architects or more tech leads. In other words, you need more people to go run those teams, and hopefully those projects will get to successful conclusions. So one of the things I ended up doing in the company I worked for was I put together a training program for our internal developers to help them move up the ranks and basically get to architecture roles. So we used to teach them the various skills and sorts of things that they would know and the background knowledge and stuff. And that's what ended up being my book, essentially. So my book is called Software Architecture for Developers. And what I wanted to do was write the book that I wished had existed when I moved into my first architecture role. So it's kind of very condensed. It's not going to tell you everything about software architecture, but it's going to be very hands-on, very lightweight, very pragmatic. So it's like, what are the essential things you need to know if you're moving into an architecture role? So that's I think the biggest problem. It's people skills and soft skills, and also figuring out what on earth should you do day to day.
I noticed another thing. I noticed these things, and especially when you talk about people skills, it's also an architect communicates with different types of people. Often you need to communicate with business people, with product people, with developers, and you need to use different language for each of these groups. But I also noticed another thing that was difficult for programmers, and I'm curious if it fits your experience. As a programmer, when you write the code, it usually, if it works on your computer and you've tested it properly and so on, it tends to work on many other computers. But when you are an architect, you need to consider also things like, computers fail. Network cards can go down, internet can break, your hard drive may be exploding and things like that. And it's very hard to move to this kind of higher risk. Is not huge risk, but it's a bit thinking in terms of a higher risk. Have you seen this with the developers?
Yes, definitely. I think when people move into their first architecture role, they tend to be of the impression, yeah, of course it's going to work. I've never had any major problems in the past, unless they've seen a major outage or anything. And you're right. I think there's a mind shift in that you have to start thinking, well, what if stuff goes down? What if we do have a security breach? And you have to be careful how you do this, because sometimes it comes across as if you're very pessimistic, like, oh, everything's going to break, so we need to overly harden everything. And maybe that's not the best approach, but you do need to kind of have that middle ground. So there's a bunch of stuff that's definitely not going to happen, but it might do. And there's a bunch of stuff that's more likely to happen. So you have to kind of factor risks and probabilities into this. And I guess one of the things I learned was you have to look at risks, and risks have different probabilities, different likelihoods, and they have different impacts. And the key thing is, don't worry about all of them, only worry about the ones which will really affect you in a bad way. So this is why you'll see risk analysis matrices with impact versus probability, and scales between 1 to 3 and 1 to 5 and high, medium, low. And there's lots of stuff out there. A technique I created a number of years ago is called risk storming. And it's a collaborative workshop technique for a bunch of people, including architects and developers and security people and SRE people and operations infrastructure staff, to look at a proposed architecture. So something we might want to build from scratch, or maybe it's something we want to make a change to. So maybe we're looking at a major change to an existing code base. And it's basically a way of saying, right, here's the thing. What do you think is risky about this build or this change? And it's a collaborative workshopping exercise. Is very visual. You can find lots of information online about it. And doing those sorts of things are a really great way to quickly get a view of where other people think the risks are on the thing you're going to build or change. So again, it's about leaning on your team. So same thing we spoke about earlier, really. It's about leaning on your team and leaning on other people's experience and their expertise. And other people are going to view the world from a very different perspective. And this gets around the situation where you've got that one architect, that one leader making all the decisions through their eyes. So yeah, I'm a big fan of doing stuff collaboratively, and assessing risk is one of the things I like to do collaboratively.
Okay, that's an interesting approach. I didn't know you had this. It's quite sounds very interesting. I'll take a look at it. Now,
yeah, you can go to riskstorming.com. There's a nice kind of one-page overview there.
Oh, cool. So now, one thing you are known for is your diagramming model, basically. So we already had UML, which, as you mentioned, it's a huge, huge specification. I'm not sure anybody uses everything from UML, but I did use use cases and sequence diagrams and a few of the diagrams there. Usually I don't get all the way to class diagrams. Why did you feel the need to get another kind of notation for this?
I'm going to backtrack a number of years here. So let's go back to 96. So in 1996, I graduated from uni, started my first job. And I think in the first like 2 or 3 months, I went on a training course. and it was a 5-day long, 5 days, a UML training course with one of the tool vendors at the time. And we literally, so I mean, UML was like 1.1 or something there, so there's only like 8 or 10 diagram types. But we went through all of the diagram types in excruciating detail with all of these tools that we were using at the time. So from my perspective, I used UML a bit early on, not so much with the Power Builder projects, but when I moved into Java, and because it's object-oriented, UML was a much better fit. So my UML usage kind of ramped up in the early stages of my career, probably up until about 2004, when it started to kind of drop off again. Now, of course, why did it drop off? Well, if we go back to 2001, the Android Manifesto was created, and lots of people read that and they thought, great, we don't have to do design anymore. We don't have to do documentation because that's what the Agile Manifesto says. And it doesn't. We've had that discussion or whatever. But I think that was really the kind of nail in the coffin for UML. So UML was on this trajectory where the original authors had kind of stepped away and passed UML over to the object management group, the consortium who now look after it. And all the tool vendors got involved. And the tool vendors was like, well, what if we could make UML this programmable thing, and then we could press some magic buttons in our tooling and we could pop code out and generate code, and the world would be amazing. So UML kind of took that path and that trajectory, whereas the rest of the world was kind of doing this agile thing and rediscovering how to go back to basics and fundamentals in many cases. And a lot of people did misinterpret the Agile Manifesto website, where it says we value working code over comprehensive documentation. And in many cases, they thought, great, well, we don't have to do documentation now. And diagramming also got thrown away, along with big design up front and all the rest of it. So again, UML usage was quite high, early 2000s, 2004, 2005, 2006 started to drop off. And by the end of my time in London, which is kind of mid to late 2000s, the number of teams using UML was dropping very, very rapidly. And of course, what replaced it was just ad hoc diagrams, by which I mean stuff in Visio, stuff in PowerPoint, and mostly photos of stuff on whiteboards. And actually, that's still the advice many people give today. So don't use UML, have some diagram session on your whiteboard, take some photos, put that in your Confluence wiki page, and you're done. And that kind of works on some levels, but it's lacking on many others. So I will get to the C4 thing in a minute, I promise. So when I worked at consulting companies in London, towards the end of my time in London, I also started running public workshops. My software architecture for developers workshops, they were running publicly in London. And the design exercise that I do now in my public workshops and stuff, it was the same design exercise, but at the time, I was really focusing on the outputs. So I wanted teams to show us their diagrams and walk us through whether their solutions met the requirements. So we were kind of doing a much more of an architecture evaluation there. The thing I noticed after doing 2, 3, maybe 4 workshops is I couldn't understand any of the diagrams because they were just completely incomprehensible. And sure, people would come up to the whiteboards and they would start pointing to stuff, and we'd have a kind of run through of their diagrams on the whiteboards, and we'd have a conversation, and we could kind of see what the diagrams meant. But I just kind of looked at these diagrams and thought, we have to do something here, because if this becomes the norm, we're going to have some issues later on. So when I'm kind of working on my own project back then, I knew that some of my customers didn't really want to use UML. I knew some of my customers did not have the expensive UML tooling, and some of the free open source tooling at the time was pretty horrible. So I also went back to using tools like PowerPoint and Visio. And the way that I'd always thought about describing an architecture was, well, we have a thing I'm building, let's call it my system, and that's what our team is delivering. We've got a bunch of users or roles who are using the system. So that sounds like an interesting thing to capture on diagrams. And my system is going to talk to a bunch of other systems in the organization or maybe out there on the internet. So that seems like quite a nice high-level diagram. So I called that a system context diagram because it basically describes the context of the software system you are building. And then I wanted to kind of zoom in to see what was inside that software system. And I didn't have any terminology for this at the time, but basically the diagrams I drew were, so we have a web app. We're going to have a box for my Java web app. That's going to be talking to a database. I'm going to have a box for a database. So maybe we're sending stuff to a message queue. So I'll draw a message queue and have an arrow to a message queue. And that next level of diagram was really the runnable, deployable things, the things like the applications and the data store. And then if we were building a Java-based web application, we might draw another diagram to show the layering of components inside the Java-based web application. And that's really the way that I'd always kind of thought about diagrams and the way I'd drawn diagrams in Visio. And it kind of suddenly occurred to me that, oh, I thought other people did this as well, and it turns out they didn't. So when I showed my diagrams to other people, they were like, oh, these look really, really good. I'm like, oh, thank you. And it was a real surprise to me because I just thought other people did the same thing. What I've not mentioned here is actually some of those diagrams were actually done with UML notation, and some were just drawn with just boxes and lines. So one of the big conceptions about the C4 model, which I'm known for and which I'll describe in a second, is that it's a new standard notation for drawing architecture diagrams, and that's actually not the case. So the C4 model, so C4 stands for context, containers, components, and code. And basically the C4 model is a 4-level hierarchy of different diagrams to describe your software system at different levels of abstraction. That's it. That's literally the whole thing. And people say, well, layering's been around forever and people have always drawn diagrams at different levels of abstraction and detail. Correct, they have, but somehow that fell out of fashion. So the C4 model is basically just a well-known set of abstractions and a set of diagrams that map on nice and cleanly to those levels of abstractions. It actually doesn't describe anything about notation. So it's a completely notation independent diagramming approach. So you can use boxes and lines, or you can use UML, or you can use Archimate or SysML. It's entirely up to you. But the important thing here is the concepts. So just to run you through the 4 levels. So the context diagram, the top level, is basically what I described already. It's we draw a box for our system. That's the thing that we are going to be delivering as a team. We figure out and identify the different users and roles and personas who are going to use our system. And we're also going to figure out the different systems that we integrate within the environment. So that might be, sending stuff to SharePoint, or it might be hooking up with your internal Active Directory server or LDAP server for authentication purposes. It might be sending alerts out to a centralized monitoring dashboard. It's that sort of stuff typically. And that basically gives you a nice dependency graph. So it basically says, this is the thing we're building. And all of these other things that sit outside our system are really dependencies that we have to look after. And maybe those dependencies are also owned by different teams. And that comes back to the risk stuff we talked about earlier. So if you have external dependencies, you need to figure out whether they're risky or not. So that's level 1. Level 2 is the container diagram. Now, there's a really unfortunate clash in naming here. And I came up with the C4 naming around, I'm going to say 2010, 2011-ish. That's when I can find the initial traces of that name. That was before Docker. So I wanted to come up with a generic name for that second level, rather than calling it applications and data stores. I wanted to come up with a generic name that basically referred to applications and data stores and things you have to deploy and things you have to run and runtime environments. I didn't want to use the word deployment unit because that doesn't make sense, and I'll explain later why that doesn't make sense. I didn't want to use the term process because that has physical connotations. So if you're running a web application in some languages on the web server provided by that environment, sometimes that web server spawns multiple processes to run your code. So I didn't want to talk about processes. So I came up with the term container. And the reason I came up with the term container is very simple. My background's Java. And when we talked about deploying Java applications, we deploy them to servlet containers and EJB containers. So I thought that's a nice generic word. So for me, basically, a container is something like an application or a data store. So it's an app running on your mobile device. It's a single page app written in Angular or React running in a web browser somewhere. It's a back-end server-side web application written in Java or Ruby on Rails or ASP.NET Core. It could be a database schema, could be a folder on a file share, could be an Elasticsearch index, could be a message queue. It's that sort of thing, really. So the level 2 diagram, the container diagram, is basically showing the deployable, runnable internals of your software system with technology details and your inter-process communication links and that sort of thing. So that's level 2. It's worth saying at this point that that's where most people should stop. So although the C4 model does have the number 4 in the name, I definitely do not recommend doing all 4 levels. And I'm going to say that again. I definitely do not recommend doing all 4 levels of the C4 model, because this comes up time and time again. For most people, the top 2 are more than sufficient to describe their existing systems. If you want to go into more detail, so if you are building a monolithic style Java web application, you can zoom into your monolithic style Java web application and draw a component diagram showing the things in your code base that I'm going to call components and how they relate to each other. Just to kind of bring this back to my modular monolith talk for a second, for those of you who know Java who are watching, you'll know that Java does not have a component keyword. So this begs the question, how are we able to draw a component diagram based on a language that doesn't have a component keyword? And the answer is it's all about decomposition, and every code base is different. So some teams use a layered architecture, and they have a bunch of, say, controllers and business services and repositories or data access objects, and maybe you identify each of those things as being your components. Other people do ports and adapters, and maybe you identify things in your domain which become components and you show on your component diagram. Other people do package by feature, so vertical slicing. So there's no set standard way to draw these component diagrams, but basically the purpose of the component diagram is draw it if you want to show the internals of your software system. My preference here ideally is you auto-generate that 3rd level because it's quite volatile. So every time you make a code change, you could potentially change your component diagram, but you might find your top 2 diagrams actually remain as is. So once you start getting to level 3, now we're looking at kind of auto generation territory. Level 4, just to finish the story, is code. So basically what we're doing now is we're taking a single component on our component diagram and we're zooming to show the code inside it. And this is where we get back to, for object-oriented languages, a UML class diagram. So this is where we want to show the internal implementation details of, say, components. That's, from a diagramming perspective, that's unnecessary for most people. And you should definitely lean on your tooling to auto-generate these diagrams for you. So I'm a big JetBrains IntelliJ fan. In IntelliJ, I can open up my Java code base, I can right-click a package or select a bunch of code and say, generate me a class diagram from this right now. So level 4 is definitely auto-generation territory. And really that's the C4 model in a nutshell. It's a set of abstractions and a set of 4 hierarchical diagrams. And essentially all you're doing is it's like a map. So you open up Google Maps, you find Romania, then you zoom in and then you find Bucharest, and then you zoom in and then you find the districts in Bucharest, and then you zoom in again and you'll find someone's house. So it's the same concept. We've got 4 levels of diagrams that represent different zoom levels on the thing that we're interested in. And by going down the zoom levels, we're kind of isolating and removing all the other noise. So we're just focusing on one thing at a time.
Yeah, I've recently watched your talks on C4, and it's actually a very natural model. I think it's quite easy to understand. I think it's quite easy to grasp. It's much easier than UML to start with. So that's a quick win. But what I noticed, it's one thing that for every architecture or design, there are actually 2 views, generally speaking. There's a view that is static, kind of the structure view, and the other view that is dynamic. How do these things interact? What flows between them? What are the... And I noticed that this is not treated a lot in C4. How do you usually do this when it's needed?
I'm going to answer that question, but I'm actually going to pick up on something else you just said. So you said that the C4 model seems a much easier way to get started than UML. that's one of the biggest wins here. So one of the big problems I find with, that people cite with UML is they don't know where to start. So if you look at UML now, version 2.5, whatever it is, you've got what, 20 plus different diagram types. So if you're a new architect and you want to draw some diagrams and you open up your UML tool, what do you do? And that's the biggest problem. There's just, you've got huge UML specification. You go onto Google and you do a search for example UML diagrams and they're all horrible, or you try and copy them and your diagrams become horrible as well. There's just no guidance. And this is one of the things I've said for a long time. There are a bunch of people out there who really like UML and they're big proponents of it. These people need to put together a simple case study that your average corporate developer can kind of look at and go, right, I want to follow this set of diagrams as a pattern. And that's what the C4 model does. So basically, if somebody comes to me and says, right, I have a blank sheet of paper, I want to draw some diagrams, and I want to use UML, I'll say, right, we'll draw a context diagram. And now UML doesn't have a context diagram, but you can use stereotyped components and packages to kind of come up with a system context type diagram. So that would be a starting point. So I kind of hate using the word framework because it all sounds very rigid and structured, but yeah, it's a nice kind of guided approach, I guess is the way I want to put this. It's a guided approach to come up with different diagrams, and you can do that with UML if you want to. So that was my little point I wanted to make on the concept of UML. To come back to your question, static versus dynamic, static versus runtime. So if I look back during my career at the software architecture documents that I've created and the diagrams I've created, I would say that maybe 80%, maybe 90%, something in that range. So 80 or 90% of all the diagrams I've ever created as a developer and architect have focused on static structure. So I think static structure it's what most people want to know initially. So you join a new team, you got a million lines of code, you want some overview from a kind of static top-down perspective. So from that perspective, the C4 model diagrams do a really good job of describing the static structures. Static structures are easier to get going with. They do allow you to tell lots of stories. So you can take a static diagram, you can print it out or stick it on the wall or stick it on Miro or on Zoom or something, and you can trace through. So in this use case, request goes here, and then it goes here, and then it goes here. Once you start doing lots of that sort of thing, you want to start maybe looking at separating out those stories into their own diagrams. So this is why UML has things like sequence diagrams and collaboration diagrams and communication diagrams and also maybe state charts. So it's a way to describe the interaction between things and the sequence of events and the sequence of message flows and data flows and that sort of thing. Curiously, if you go back 20 years, there used to be a popular concept called Dataflow diagrams. And some of those were actually hierarchical. So you could have like a level 1 Dataflow diagram and level 2, much like the C4 model does. So we've always had this same concept in our minds. So you're right, the C4 model diagrams, the context, the containers, the components, the code, they're really just focused on static structure. If you go to the C4 model website, which is c4model.com, and you scroll down past those diagrams, there are also some supplementary diagrams. So I completely appreciate that the static structure diagrams don't tell the whole story. You can use them as a basis for the whole story, but they don't tell the whole story. So I created something I just call a dynamic diagram, and it's basically it's heavily based on a UML collaboration diagram where you're showing things and how they interact at runtime with numbered arrows. Some people like sequence diagrams. I tend to prefer the collaboration diagram approach for one simple reason: it's easier to draw. So the collaboration diagrams and the sequence diagrams actually show the same information. Some of the older UML tools you used to get, you could draft up a sequence diagram and then do right-click, convert this to a collaboration diagram, and it would show you a collaboration diagram. And you could do right-click, show me the sequence diagram, and it would show you exactly the same thing because it's essentially the same information. So with my dynamic diagrams, all I'm basically doing is I'm taking boxes off my static structure diagrams So my software systems, my containers, my components, my people. And I'm showing how a particular use case or user story or feature works as a sequence of things happening across those elements, whether those things are data flows or messages or events or whatever it is. So that's definitely there, and people do use that. But I still find people use those runtime type diagrams much less than the static structure diagrams. So that's why the C4 model focuses on static structure first. Plus it forms the basis for the diagrams.
Well, yeah, it makes sense. And as I said, it's a very powerful, very easy tool to start with. The diagrams are easy to understand. It brings just enough order so that you can actually communicate important information about architecture. But I was curious about this side as well. All right. So you mentioned about C4 and how it's quite easy to get started with it. There's the website and you have a few talks and you've already summarized very easily this. What is the tool support for C4? Because I know there are a number of tools that can be useful.
So tool support for the C4 model ranges from your basic drawing tool, like Visio, OmniGraffle, draw.io/diagrams.net was just recently rebranded, Creately, Glyphy, like any tool that you can use to draw boxes and arrows. MS Paint if you really want to, but don't do that. Any tool that you can draw boxes and lines with, you can draw C4 model diagrams. So again, because the C4 model doesn't prescribe a notation, you can use pretty much any drawing tool you like. Having said that, I don't recommend using drawing tools for software architecture diagrams. And there are a bunch of reasons, but the main reason is that it's easy for your diagrams to become out of sync. So let me explain with a simple example. Imagine you're working on a team and you've drawn a nice system context diagram, which shows your people and your external dependencies. To draw a container diagram, what you basically do in a drawing tool is you select all those boxes you've just drawn, you copy them, you open a new diagram canvas, and you paste them into that second canvas. So now you've got all of your people and all of your software systems, no work needed. And you draw your container diagram and fill in all the blanks and add the lines. What happens a week later when you want to change the name of one of your user types or the name of one of the external systems on your diagram? We have to do it in two places because you've copy and pasted information. That's fine if you've only got 2 diagrams. If you've got 3 diagrams or 4 diagrams or 5 diagrams, or you've got a system with like 50 other system integrations and it all looks a bit complicated and you're time pressured, you're going to forget to rename elements across your diagrams. So most diagramming tools are diagramming tools. They are for diagramming and drawing, and the domain specific language of diagramming tools is basically shapes. It's various shapes and connections between them. So when we're drawing a box with a drawing tool, the tool doesn't know that this represents a person or a software system or an interesting relationship over HTTPS. It's just a shape, and it doesn't really care what you're doing with it. And so therefore the drawing tools don't know what you're doing, and they don't really understand that one box on diagram 1 is the same as another box on diagram 2. So although you can get away with using diagramming tools, and that's a place where most people start, and there are some templates online. So you go to c4model.com, there's a tooling section, and I've linked to templates for draw.io and OmniGraffle and Visio. So if you want to get started very simply, those are some templates you can use. And to be fair, the templates don't do much, actually. All the templates do is give you some pre-built shapes with some text placeholders, and you can double click and change the text, and it saves you 4 seconds or something. But there's some nice coloring and stuff going on there as well. So we're going to move diagramming tools to one side. I think diagramming tools makes up like 90% of what people do these days. I'm going to throw whiteboards in there as well. There's been a trend recently towards text-based tooling. by which I mean things like web sequence diagrams or plant UML or Mermaid. And there are a bunch of other tools that do the same thing. So basically, rather than drawing boxes, lines with a mouse and a keyboard, you're just using a keyboard and a text editor. So with something like plant UML, there's a specific plant UML domain-specific language. And you say, basically, I want to draw a component diagram. And you kind of list out the components you want to include on the diagram. And there's a language and a notation and text for doing that. And then you describe the relationships. You save your text file. You pass it through the plant UML interpreter and tooling and renderer, and it auto-generates a diagram for you. Now, many of these tools use automatic layout algorithms like Graph is behind the scenes, but essentially you get a diagram with very minimal effort. Now, this is super nice because as developers, we like text. So as a developer, I have a whole bunch of tooling on my laptop here that is built for messing with text. Using a text-based tool also solves, to some degree, changing names. So if you've got two diagrams, you need to create two text files with your two plant UML definitions, one for each diagram that you want to generate. If you want to rename a box on two diagrams, you can open up both files in your IDE and you can do a global search to replace. So that helps with the renaming issue, if you remember to do it, of course. We can version control text. So now we can see the differences between diagram versions and therefore how our architecture changed over time, if we remember to update diagrams, of course. They're lightweight. Many of the text-based tools can be embedded in GitHub READMEs and ASCII documents and Markdown documents and Confluence pages. And there's a nice plugin for Visual Studio Code that does plant UML rendering and visualization as you're typing away. So there's lots of nice tool support from a developer perspective. From a C4 model perspective, there are a whole bunch of plant UML extensions. Maybe macros is a better term. So you start drafting up your plant UML file and you say include this macro from this GitHub address. And then rather than talk about generic UML components, you can start talking about people or software systems or containers. So many people have built a C4 model style domain specific language on top of plant UML. So now you can say person A, software system B, A uses software system B, save the file, generate a system context diagram. So there's a bunch of stuff out there and it will do things like put the text placeholders in the right place and encourage you to add names and descriptions on relationships. And it will use some of the color coding you might see on the example C4 model diagrams. Although, as I said before, there is no standard notation. So that helps. And those types of tools are becoming more popular. If you really want to go for it, you can go for the traditional style modeling approach, by which I mean you go get rational rows, you go get rational software architects, Sparks, what are you laughing for? Sparks Enterprise Architecture, Sparks Enterprise Architect, Visual Paradigm. There are a whole bunch of traditional modeling tools out there, and Archie as well, Archie. And these tools tend to support one or many notations, typically UML plus Archimate plus SysML. And although these tools are not really built for the C4 model, you can use the existing notations and again just make sure you structure your diagrams in the appropriate way. For the free Archie tool, which is an Archimate modeling tool, there is, I think it's a plugin or an extension that allows you to do some things and make creating C4 model diagrams easier. And there's a company in the Czech Republic who have built some add-ons for Sparks Enterprise Architect that again makes building C4 model diagrams slightly easier. So you can do the modeling tool approach if you want to. I don't see people doing that at all very often these days. The people I see using modeling tools tend to be using it for a reason. In other words, they are forge generating code for a very specific reason. That's quite a niche market these days. Or they're a very big company and they've been forced to use some modeling tool. That's typically the reason people use modeling tools. So that was basically the tooling landscape up until I'm going to say 5 years ago, and I felt quite disappointed with it, if I'm honest, because it just seemed a hassle. So when I want to create software architecture diagrams, I want them to be nice and visually appealing, and I want to do it super quickly. So I thought, right, I have to stop recommending videos. So people would ask me after my workshops, we love the C4 model diagrams. What tooling do you recommend? I'd say, well, just use Visio OmniGraffle. That's basically as good as it gets these days. And that bugged me. That bugged me a lot. So I thought it's finally time for me to build some tooling. So about 5 years ago, I started a company up that's called Structurizer. And over the past 5 years, I've built a whole raft of different tooling. So this is all specifically targeted at the C4 model. My Structurizer tooling does not support business process diagrams, activity diagrams, entity relationship diagrams, and state charts. If you want to draw those things, there are perfectly good tools out there. So this is really just focused on the C4 model diagrams, so the 4 static structure diagrams plus the supplementary diagrams, so the dynamic runtime thing. And I've also got what I call a system landscape diagram, and also there's a deployment diagram that shows the mapping of C4 model containers onto infrastructure, essentially. So I built some tooling, and it's a plethora of tooling, and it ranges from free and open source to paid and commercial, with everything in between. So I'm trying to figure out the best way to summarize all of the Structurizer tooling very simply. So let me start with the paid option first. So the paid option is basically it's a web-based tool that does diagram rendering. So it runs on the cloud or on premises, and you upload a definition of your architecture, and it will render those diagrams for you, and you have control over shapes and colors and layout and things like that. So I think it's a nice renderer for drawing the C4 model diagrams. This begs the question, how you create the definitions of architecture. And what I've learned over the years is many teams want very different approaches to how they describe architectures. So some teams want I want to open up a tool and kind of click around and drag stuff around, and they want a very kind of user interface driven approach to building diagrams. So Structurizer provides that, and there are free and paid options for that as well. So it gets very complicated. Other teams want to do I want to create diagrams as text approach. So up until fairly recently, the only way you could do that was there are a bunch of open source libraries. There's one called Structurizer for Java that I built first, and then there's a Structurizer for .NET that I built afterwards. There are now ports to PHP, Python, TypeScript, and Go. And basically what you do is you write a short program in the language of your choice, and you use the Structurizer for the programming language library. And basically that library has all the concepts like people, software systems, containers, and components. And all you're really doing is you're writing a program that creates instances of these things at runtime, creates an in-memory object graph. So essentially an architecture diagram is a directed graph. So you're creating a description of your architecture using the classes and the interfaces and APIs provided by the client libraries, the Structurizer for Java client library, for example. And then you run this program. So this program is essentially a description of your architecture diagram. You run this program and it converts that to a JSON document. That JSON document then gets uploaded to the Structurizer web service, which will render the diagrams. When lockdown happened, because I do lots of workshops, I found myself with lots of time on my hands. And one of the things that people had been wanting to do is they wanted a way to create the C4 model diagrams using a much more kind of non-code, more textual DSL based approach. So I built one. So there's something called the Structurizer Dsl, which is essentially a wrapper around the Structurizer for Java client library. And it allows you to describe an architecture diagram in a really, really condensed, lightweight textual format. And then you can use, so that's all open source. And then you can use the Structurizer command line interface tool, the CLI tool, which is also open source, which I also built during lockdown because I had lots of time on my hands. you can use the CLI to do a number of things. So you can take your Structurizer Dsl definition, your text file, you can push it through the CLI and push it up to the Structurizer service or the on-premises installation and use the Structurizer renderer. Again, free and commercial pricing points there. Or the command line interface will allow you to output to Plant UML or Mermaid or web sequence diagrams or a tool called Elograph. I think it's called Elograph. Now this is super powerful. Remember the problem I told you about before where we have two diagrams, we copy a box from one diagram to the other, we want to rename one of the boxes, we go and make sure we rename it twice. That's hard with diagramming tools. I also said that Plant UML solves this issue a bit because now we can open up our two Plant UML definitions. We can load them into our IDE, do a global set to replace, and we get both instances at the same time. With the Structurizer Dsl, it's not a tool for doing diagramming, it's actually a tool for doing modeling. And it's at this point people go, whoa, hang on a second, you snuck that in. So I'm not talking about big, heavyweight, old traditional style modeling. I'm basically talking about if you have a person and you want to show that person multiple diagrams, let's just define it once. So in software development, we talk about don't repeat yourself, don't be dry. But that's exactly what we're doing with our architecture diagrams. So the Structurizer Dsl basically lets you define a bunch of concepts and how they relate to each other. And then separately later on in the file, you describe the different diagrams, the different views, to use the proper terminology. You describe the different views that you want to show onto that set of elements and relationships that you defined. And the views map onto the C4 model, so you can draw a system context diagram, container diagram, and so on. So the Structurizer Dsl is actually a diagramming tool agnostic way of describing architecture models and views onto that model. And that's where this gets super powerful, because now you've got a tooling independent way to describe an architecture diagram, and you can output it to a whole bunch of tools. So maybe you want to try my Structurizer tooling and you don't like it for some reason, or maybe you can just use Plant UML instead. So this text-based approach actually reduces vendor lock-in because you can now switch from diagramming tool to diagramming tool. And every diagramming tool has its own strengths and weaknesses. And basically you get to try them all. So that's the most recent addition to the tooling story for the C4 model. So the Structurizer Dsl is a text-based DSL, quite condensed, and it allows you to target multiple diagramming tools. So if somebody now asks me, what do you recommend I start with for tooling for generating C4 model diagrams? I will say start with Structurizer Dsl and try all of the various diagramming options to find the one you like the best.
You mentioned, I recently started trying Plant UML, and I think it's a really cool idea because you can version control, you can store it in text and so on. And so it's great to hear that you have this for structurizers as well, in a way that's higher level, in a way that's specific to the model, and it allows you to basically build this and also preserve and version control and so on. That's very powerful.
I mean, you're right. It's a way to define a model in a diagramming tool agnostic way. So I also like Plant UML, but Plant UML is a diagramming tool. It's not a modeling tool. I'm more than happy to recommend people use Plant UML, but I don't recommend they hand type the Plant UML. I think they should generate it from a model instead.
Yeah.
And that's super easy to do now.
I mean, Plant UML it can get out of hand when you have a lot of things. If you are just starting, if you're just doing 2-3 diagrams, it's fine. But if you all need a lot of diagrams, you need a higher model behind those. That's really cool. So I'm glad to hear that you had some more time to work on Structurizer, because the last time I think it was only Java code when I saw you could create, which was an interesting model, but I guess it's not the best or not the simplest way of building.
Yeah, and I think the biggest criticism I've had is that not everybody on a team knows Java.
Yeah.
Then you go, because you say, well, we have a .NET version, and then you get the same excuse, not everyone in the team knows C#.NET. So there's no single programming language you can pick that everybody knows. With a text-based approach, everybody has to learn it, but hopefully the text-based approach has a much lower barrier to entry.
Mm-hmm.
The other thing that I really like about text-based approaches is that you don't have to hand type the text. So I just mentioned that people should not handcraft plant UML definitions, and they should generate them from a model instead. You could also generate that model. So there's nothing stopping you building some tooling to reverse engineer your existing AWS environment, get the output of that parsing effort, generate a Structurizer Dsl file, which you can then forward and engineer into plant UML. So the nice thing about having diagrams as text is you have the potential to handcraft and or to generate parts of that text definition. And I think that's going to be the interesting thing going forward. There's lots of people now saying we have these very complicated distributed architectures with serverless functions as a service and microservices, and we don't want to handcraft our architecture diagrams because the second we do that, they're out of date. And there's lots of people looking at how do we auto-generate real diagrams off our real running systems. And of course, having diagrams as text still keeps that door very widely open for you.
Right. So that's really interesting. I can't wait to give it a try. So I think C4 is definitely a very interesting part of this. But what I like to do before we end is to look a bit at the trends in the industry that you see. We already discussed a bit about serverless and cloud and microservices. To me, it seems like it's kind of going down a little. At least there's not so much buzz anymore. I guess many people are struggling with their architecture now, but it doesn't have so much buzz. But there are other things like design patterns, architectural patterns, and so on. So I like to get your views on some of these. How useful are design patterns to you or have been to you? How useful have been things like enterprise integration patterns to you? Should somebody who is learning architecture look into those or not?
There was an interesting thread on Twitter recently about design patterns. Somebody said they tried to read the Gang of Four design patterns book and basically just gave up. It was a horrible mess and no one uses it. And that's, I think that's a bit unfair. I think if you look at when that book was written, which was mid 90s, it was kind of a seminal work at the time because people were just getting into mainstream object-oriented programming, Smalltalk and C++, and of course later on in that decade Java. And I think a lot of people were looking for inspiration about how do we take all of this code and these classes and these interfaces and how do we apply some structure to it. And now, of course, all those design patterns are still super useful, but many teams don't build them themselves because, as somebody rightly said, a lot of the approaches, many of the good approaches are now built into either the languages we use or the frameworks we're using instead. So those design patterns are kind of still kicking around, but they're maybe at a lower level of abstraction. And 20 years ago, you'd go into a design meeting and it would be people discussing about the builder pattern and whether we should have a facade or an adapter. And you don't have that anymore for a bunch of reasons. Number one, we don't have collaborative design meetings to talk about code anymore. People are doing test first or test-driven development instead, so they're working on their own, or maybe they're doing mobbing or pairing or whatever. So we tend to take different approaches to doing design and coding anyway. So design patterns, worth having some knowledge. I wouldn't necessarily recommend everybody goes and learns out the canonical implementations in their language of choice for all of the different design patterns, but having some overview knowledge is useful. Same with enterprise integration patterns. Lots of the systems people are building these days, especially if they are microservice based or serverless based, or they have some sort of distributed architecture, they want to scale, they put message buses in there and Kafka and all sorts of other stuff. Lots of the techniques from the enterprise integration patterns book people are using. A lot of the time people are not aware of these patterns. It's just funny, you go have these discussions with people and they'll tell you about their problems and you'll think, oh, I know exactly what you're doing because I read about this 20 years ago in a book. So again, for people new to an architecture role, I definitely go and buy a copy of the Enterprise Integration Patterns book, have a flick through it, familiarize yourself with it. Maybe don't deep dive into all the different patterns, but again, there's some useful stuff in there. I was actually at a conference a number of years ago, and I was sitting next to two people. There was one guy who was like an industry veteran. I can't remember who it was now, but he's been around for like 30, 40 years. And there was a guy sitting next to him who was doing a project in like Rust or Go or something, like something super modern. And they were talking about this problem he was trying to solve. And the veteran guy basically said, yeah, that's exactly what we used to call this 30 years ago. And that's the interesting thing is about trends, isn't it? I'm not sure we're creating any new trends, but we're certainly rediscovering, often by accident, of course, some of the older trends and some of the older ways to do things. And I think we need to do a better job at teaching people history.
Yeah,
because we don't.
I agree. I started recently digging through Art Cunningham's wiki, which is the first wiki, and it's fascinating because it has a whole history of design patterns and object-oriented programming and extreme programming and agile. So it's very interesting to go through there, and you keep digging out new conversations and things. And one of the interesting things about design patterns, for example, is that, as you said, when it started, it was an exploration of how we can use and reuse certain elements in our designs. But then it got developed, but not many people know that. The focus now of the community around design patterns is more around building pattern languages, which is a different thing. A pattern language can be specific to an application. This is something I've actually done for one of our products. So I started by building kind of a pattern language, and it's similar to what a UX designer would do to build a visual language for an application, just to preserve a certain consistency inside the architecture. Right. And you can do these types of things, and these are actually extremely useful, extremely powerful. And as you said, Design Patterns is a book for its own age. And now most of the things are actually inside the frameworks. And you mentioned...
it's the power of the ubiquitous language, isn't it?
Yeah, it's no longer...
DDD calls about this, talks about this, figure out what your ubiquitous language is. The C4 model does exactly the same thing. It's like, here's a bunch of named things, now let's go use them. And we all know what we're talking about.
You also mentioned test-driven development. What have you had clients who are doing test-driven development or adopting, and what was their experience?
I'm not really sure how to answer this question, because every time I go into an organization and I ask them questions like, are you doing TDD? A lot of them will say, yes, we do TDD. And you go, okay, great. How's it working? They're like, yeah, it's wonderful. Perfect. And then like an hour or two later, they'll talk about something, and it turns out that they're writing tests after writing production code. You're like, well, hang on a second. I'm not sure that's what TDD means. And they're like, yeah, but we're still writing tests. I'm like, well, yeah, but I asked you whether you're doing test-driven development. And they're like, yeah, but we're writing tests alongside code. And like, oh. And then you get into this whole discussion of test first versus test afterwards. And I don't know what TDD means anymore, if I'm honest with you. I think we're getting to a point where most teams are writing tests. I think, because I have met teams and they've asked me, do you think we should look at some of these automated unit testing frameworks? I've gone, yes, even recently. So I think most teams have discovered the benefit of having a good test suite. Whether people write the tests first or afterwards or at the same time, I don't know.
Yeah, this is often the case I've seen, but it's interesting to hear from you, because my impression is that in London there's a strong XP community, which is quite, let's say, old. It has a tradition, and but it doesn't seem to spread that much into enterprise environments or that fast as a technique.
Yeah, so I worked in London at the same time a lot of that XP stuff was going on. I never worked for ThoughtWorks or any of the companies who were directly involved in it. Connextra, for example, as well. I think it's companies. Is that right? Connextra?
Maybe.
So I definitely saw lots of this stuff kind of happening from a distance, and I did kind of peek my head through their meetups occasionally and have a look what was going on. And yeah, it was a kind of very vibrant, vocal community around a lot of the agile XP stuff at the time and TDD. And you're right, getting that stuff to spread into your typical investment bank in London, for example, is a significantly hard task. I've had some very big companies very recently get in touch and say, right, we're starting our agile and DevOps transformation. I'm like, oh my goodness, it's like 2020. What is going on here? So sometimes these ideas do take a long time to catch on in big organizations.
All right, so we are getting close to the end of this conversation. Is there anything that you would like to share with our listeners before we close? And then I have one last question about some advice for young developers who are just starting.
So I guess closing comments for me, if people are interested in the C4 model, you can go to c4model.com. And there's a kind of long single page website that tells you pretty much everything you need to know. There's a video linked right at the top of that page, which is it's a talk from a conference I did last year, I think it was. So if you want a nice like 45 minute introduction to the C4 model with example diagrams and slides that I point to and kind of explain why they're good, that's a really good starting point. If you haven't got time for a 40-minute video, there's an article on infoq.com, and again, that's linked right at the top of the C4 model page, and it's like a 5-minute introduction to the C4 model, but I would definitely recommend watching the video first and watching it through to the end. I often get questions from people like, how do we do this in the C4 model, or what would you recommend for doing X? And like, just watch the whole video. And what they've done is they watched the first 20 minutes, got to the C4 thing, going, right, now I know what I'm doing. And there's a whole bunch of really interesting advice and tips around notation in the latter half of the video. And a lot of the questions people ask is like, if I'm building a message-based architecture, should I show the message bus? Because then everything points to the message bus. Is that a good thing? And those sorts of questions that I described on the video. So yeah, I definitely recommend watching the video. So c4model.com is a good place to go. And also if you go to my website, which is simonbrown.je, because I live in Jersey, of course, there's a bunch of other conference talks linked to there around the topic of software architecture.
Yeah, and I have to concur here. I watched that video, and it's really good. It's worth spending 45 minutes or how long it is watching it, because it gives you all the necessary information to get started, and then the rest is up to you how to learn more. All right, so it's a different kind of time nowadays with a lot of developers, new technologies, a lot of different types of architectures, cloud, JavaScript taking over the world. Is there any advice that you would give a new developer who wants to do a good job and who is just starting, or a junior, has 3 to 5 years experience, something like that? Anything that you think could help?
That's a really tough question. I think the best advice I would give somebody starting out now today is to not get carried away with all the fashion and all of the hype and all of the trend. So that's going to give you very short-term satisfaction. So you start on projects, it's all microservices with Kubernetes all stuffed in AWS, and it's all wonderful, and you're using Rust and Go and or doing all this cool stuff. By all means, do that stuff and learn that stuff and have fun doing it, but make sure you also understand the stuff that sits behind it. So focus on the fundamentals. And that's things like patterns, as we've already discussed. It's things like watching how the team operates. Just basically try and figure out the stuff that you can take from project to project, from team to team, to company to do a better job. And that's the thing I think we miss in the software development industry. Every conference you go to, it's like trend, fashion, hype. And I think we need to have some more content around the fundamentals. So my tip for new developers is focus on the fundamentals. Go buy some old books. Seriously, you can pick up some of the older books on Amazon for like £3, like $3 or something. There's some really good stuff in there. Maybe you don't read all of it, but there's some good stuff you can pick up from some of the older books. Go watch older videos about software development from conferences and things.
Thank you, Simon. You've been very kind, and this conversation has been very interesting. I'm glad to hear that you managed to develop some more on Structurizer. I can't wait to try it out. So for all of you, you've heard, I think, a lot of interesting advice about architecture, about what to learn from architecture, about what to learn as a new developer and what to look at. We plan to do much more conversations like this, and we'll keep going. But for now, I'd like to thank you for listening. If you like this, you can share, subscribe to our channel. And until next time, remember to think, design, and work smart.